Yeah, hi guys, good evening. I think I'm audible to all of you guys. Let me know if I'm audible. Yeah, hi guys, good evening. Okay, so thanks for joining. Real animation is telling nice. Yeah, thank you. And I'm extremely sorry, guys. I was busy with some work. That's why there was a little bit delay in my live. So I have rescheduled this live multiple time. I think 2 to 3 times. Extremely sorry for that. Thank you. So, welcome to day 14 of our computer vision for developer series. And today I'm going to discuss the object detection in computer vision. Okay. So we have completed till image classifications and we have learned so many things inside computer vision. Let me show you the entire playlist. So I think I have to share my screen. Just a minute. Yeah, so guys, I think my screen is visible. You can see my screen. So this is my YouTube channel, and if you go to the computer vision for developer playlist, so see, we have completed till day 13. Okay, and I have also covered like how we can perform image classification with the help of PyTorch as well, right? So each and everything we have done, we have already clarified the foundation. Now you are ready to export everything inside computer vision. Okay, now one of the amazing interesting task you will be getting inside computer vision called object detections. Okay, and this is very interesting task because real time you can detect any kinds of objects. So far we have seen how to classify image, right? So let's say if there is an object present inside an image, I can classify whether it's a cat, whether it's a dog, whether it's a tomato, whether it's an apple, right? But let's say inside an image you are having multiple objects. Okay, you are having multiple objects. That time what to do, right? That time what to do? So Keshav is telling, sir, please also do NLP same way. Definitely, I'll keep in that in my mind. I will also start an NLP series. Okay, no need to worry. Yeah, hello Madhav, hello everyone. Thanks for joining. So see, what is the difference between object detection, image classification? I think I already showed you. Let me show you again. So if you search like image classification, object detection, and segmentation, so you will be getting an image in the Google. So this is the image I think I can utilize. So let's copy. I'll open up my board. You can just message me over my LinkedIn. Okay, we can connect, Madhav. So this is my LinkedIn profile, guys, by the way. So you can connect me here. You can also follow me. You can connect me. Hmm. So see how I'm going to teach you the object detection. First of all, I'm going to show you a practical, okay, practical demo. Yeah, I already showed you my LinkedIn profile. This is the name. You can search Boktiar Ahmed Bappi. Even it is also available in my description. Okay, YouTube channel description. From there also you can get it. Boktiar Ahmed Bappi. This is my profile. Yeah. So see how I'm going to teach you the object detection. First of all, I'm going to show you the practical demo. Okay. After that, I'm going to discuss the theoretical part. I think you know that in object detection also we use some model. We use some algorithm, right? I'm going to show you what are the algorithm we have inside object detection. So each and everything we'll try to explore one by one. Okay. First of all, let's try to understand about the object detection. What is object detection is. So this is the difference between classification, localization, object detection, and instance segmentation. So we have seen like how to do the classification. Okay. So after classification, there was another task researcher proposed called classification and localization. That means it will classify it's a cat. Even it will also locate it is a cat. So let's say here this cat is present. But this thing we don't use. This localization concept has been deprecated. So researcher proposed something called object detection. Okay. Why object detection? Because let's say you are having multiple images, multiple object inside an image. That time how it will detect. Let's say here I'm having dog, I'm having cats, I'm having duck, I'm having different objects. Now I also need to understand the location of the objects, and I also need to classify what particular object it is. So this is why audio object detection comes into picture. That means you're not only classifying, you're also detecting the object in that specific position. Okay, so this is the main difference, guys. And because of the multi object present inside an image, object detection you have to use. Whenever you are having single object, it is completely fine. Okay, it is completely fine, you can use classification. But whenever you have multiple object, there is a possibility inside your image there would be multiple object. That time try to apply object detection on top of it. No, today it is not about YOLO session. Yeah, I might show one demo, that means practical demo with the help of YOLO, but this is not a YOLO theoretical session, Shafin. First of all, we'll try to understand like faster RCNN, then we'll be understanding the SSD, then we'll be understanding the YOLO. Okay, that's how we'll be understanding each and everything. And what is the segmentation? Segmentation means, let's say here you can see some background are available, okay, in the box. But let's say you don't need the background, you only need the object. That time you can apply something called instance segmentation. It will segment that object only. Okay, it will create a mask. This is called segmentation. We'll also learn the segmentation going forward. So first of all, let's try to understand the object detection. Okay. Now, can you tell me, guys, some application of object detection? Can you tell me some application of object detection? Real-time application. I can apply object detection anywhere. Okay, to detect the pedestrian, to detect the car, to detect the license plate. Okay, to detect the bird, to detect, let's say, different mechanical equipment, to detect different let's say let's say component in industry. So anywhere you can apply this object detection. I think recently I updated one video in my channel, so I don't know if you have watched or not. So if you go to the video section, so have you seen this robotic arm demo, guys? How many of you have seen this robotic arm demo? Let me know. If yes, just write yes in the chat. Otherwise, just write no in the chat. Let me show you this arm. So this is the arm setup. So here you can see I'm using real-time camera. So here I'm using one camera, and there is a stand you can see. In this stand also I'm using another camera. So let's say whenever I'm passing any kinds of object here. Okay, let's say whenever I'm passing any kinds of object, that means this particular cube. Let's say here I'm passing the cube. So here it will doing the real-time analyze. What is the real-time analyze? First of all, it will check what kinds of object it is, whether it's a square shape object, whether it's a round shape object, or whether it's a any other shape object. So here I will only allow square shaped object, a square shape red color cube, square shape red color cube. If you are passing anything else instead of that, it will not allow that particular object. Okay, so see, this time this kinds of real-time verification is happening with the help of this object detection. You can see. So in the screen, computer screen, I think you can see there is a camera, and it is performing the object detection to identify the shape of the object, whether it's a square shape, whether it's a round shape, or whether it's any other shape. Okay, then after detecting the object, I'm also detecting the color, whether it's a red color, whether it's a green color, whether it's a yellow color. Okay, based on that, I will decide whether this object will move to the next conveyor belt or not. Okay, so this is another amazing example you can use object detection, because these kinds of applications are available in the industry. So those who have seen like automated robotics industry, so they're using these kinds of conveyor belt system to let's say manage their product, manage different let's say courier product. Have you seen, guys, these kinds of automated courier system? So let's say some parcel are coming na, so they're real time doing the scanning operation with the help of QR code, or let's say color, or let's say box, any kinds of barcode, and they're moving that parcel to different container. Have you seen this kinds of application? I think abroad country they are using these are the application. Okay, but in our country people are hiring labor, okay, for that. Even if you see like automatic bottle filling system, they are also using this kinds of arm. So there are thousands of applications are available. You can apply object detection on top of that. Okay, so if I'm talking about self-driving car, So there also you have to detect the object, whether it's a person, whether it's a cat, whether it's a dog. Based on that, you have to decide, right? So anywhere you can apply, guys. I'm going to show you some project. You will be enjoying a lot. Trust me, you will be enjoying a lot. Now in object detection, guys, in object detection, we use some model. Okay, we use some model. Like for image classification, I think you saw some pre-trained models are available, yes or no? Can you name some pre-trained model in image classification? Tell me some image classification model name we saw before. Just write down, guys, in the chat quickly. VGG16, ResNet 50, Inception V3, right? So these are the models are for object classification, okay? But whenever I'm talking about object detection, in object detection, we are also having some model. We are also having some algorithm. The first model comes into picture called called RCNN. RCNN. Okay. Then we have fast RCNN. Then we have faster RCNN. Then we have single shot detector, that means SSD. Then we have YOLO. Okay. Now, see, nowadays this RCNN is deprecated. Fast RCNN is also deprecated. You will see all the models are available in the faster RCNN architecture. Okay. And SSD and YOLO. See, at the end, YOLO uses SSD architecture only, SSD concept only. Okay. So if you understand YOLO, you don't need to learn the SSD, because at the end, SSD we don't implement. Okay. SSD we don't implement with our code. We implement the YOLO. Okay, and YOLO is like very powerful model, trust me. YOLO is having different variant, like it is having YOLO V5, V6, V7, V8, V9, V10. I think V11 is also available. And whenever I'll show you the demo, it will be amazing. You will get surprised, like what are the tasks you can perform. Okay. And with the help of YOLO, recent version of YOLO, you can also perform image classification, segmentation, key point detection, even object detection. All of the tasks you can perform with a single model. Right. So that's how architecture is evolving day by day. So initially we used to use RCNN architecture. Then there was a problem with the help of in the RCNN architecture. Then a researcher proposed something called fast RCNN. So what was the main problem with the RCNN? It was very slow that time. Okay, it was very slow. So they proposed something called fast RCNN technique. So it was quite fast than your RCNN. Then again, there was a problem with the fast RCNN. Then researchers proposed something called faster RCNN. And this method actually was amazing, like concept they proposed there. I'll tell you, whenever I'll show you the theory, that time I'll discuss what is the architecture of faster RCNN, what are the component they have introduced, okay, how their like working mechanism is and everything I'll clarify. But first of all, I told you I'm going to show you the practical. Okay, I'm going to show you the practical. Yes, today is technical. Today I'm going to show you one object detection practical. How object detection can be happen. How we can prepare the data. How we can annotate the data. How we can do the object detections. Okay, then after understanding the practical, in the next class I'm going to show you the theoretical understanding. Okay, how we can use the theoretical understanding. That's it. Is there any code for auto annotation? Auto annotation, see, auto annotation at the end there are some platform are available, Shafin. You can use that for auto annotation. Like RoboFlow also gives you auto annotation functionality. There are some multi models are available. They with the help of that you can also perform auto annotation. Okay, So yes. So I hope guys you understood the entire flow of the object detection. So RCNN and faster RCNN we're not going to explore because this is deprecated. Nobody uses nowadays. We'll start from faster RCNN. Okay. We'll try to see the architecture. We'll try to see the theoretical understanding of the faster RCNN. Even I'm also going to show you the practical how we can do the object detection with the faster RCNN. SSD at the end, I'm going to give you the overview how SSD works. But practical wise, I'm going to show you the YOLO because at the end, YOLO uses SSD architecture, okay? And on top of that, they did some modification at the end. Got it? And framework wise, I'm going to show you Detectron 2. Detectron 2. This is developed by Facebook and YOLO. Okay, YOLO. So this two framework we'll try to see guys. For the object detection task. There was another framework called TensorFlow. TensorFlow OD, object detection 2.x. But at the end, this is like very hard to set up. Okay, this is hard to set up, and even this is not that much of good, and nobody likes this TensorFlow OD framework because there you have to do manual configuration, manual setup, and it will give you lots of error. Okay, if you want to set up this. So let's say it will take 1 hour of time, okay, to do all the configuration. Then you can do the training operation again. After training again for the inference, you have to do the same configuration. That's why I'm not going to use TensorFlow OD. Okay, so this thing I'm not going to use, guys. So let me tell you, I'm not going to use TensorFlow OD. So please don't ask me later on why I'm not using TensorFlow OD, because if you see TensorFlow OD, TensorFlow object detection API. So it was 1.x, but 1.x already deprecated. Okay. In this one. Where is the 1.x tag? See, 1.x is already deprecated, so nobody uses 1.x. They then proposed they proposed actually 2.x, but 2.x is not that much of good because here you have to do so many configuration, and I can see this repository is not that much of active. So the last commit was 2 weeks ago, and if you see the all the commit now, so you'll see like see, this is not that I mean not an active resource. Okay, and if I show you the YOLO GitHub, it's very active resource. YOLO v11. See, last commit 1 hours ago. Okay, and it is very easy to use. Very easy to use. And you can see there are lots of contributors also available. Even you can also do open source contribution if you want. And there is another framework called Detectron 2. Detectron 2. So this is developed by Facebook. So with the help of Detectron 2, you can perform object detection, you can perform image segmentation, you can perform key point detection. Okay, all of the tasks you can perform. So first of all, we'll explore for the object detection, and it has actually different models like faster RCNN. Let me show you faster RCNN backbone. It is available. See, faster RCNN. We'll export the faster RCNN. Okay. Then there is another model called RetinaNet. Then RetinaNet, it is also available because RetinaNet they have developed. Okay, and this is the same variant of faster RCNN only. Okay, and image segmentation also they are having different model. You can see Coco instance image segmentation, mask RCNN. So for a segmentation task we use mask RCNN model. Yeah. So that's why I'm not going to explore the TensorFlow. Instead of that, we'll explore the Detectron 2 and YOLO. Now to perform object detection, the first step guys, you have to do the data collection. Okay. Now data wise, you have to collect image data. Okay, image data. Now it can be any kinds of image based on your task you want to perform. Let's say today the example I'm going to show you, I'm going to create a sign language detection system. Okay, so let's say I'm having different sign. Let's say those who are dumb people, na, so they use different signs to express their language. This is called sign language. Okay, you can search here what is sign language. Sign language detection. So see, these are sign language. Okay, so we'll try to build this kinds of system. So if you show any kinds of sign, it will try to detect what kinds of sign it is, whether it's a hello, whether it's a thank you, whether it's a sorry, okay, whether it's a, let's say, yes, no, this kinds of thing it will detect. Now you can collect these kinds of data from the internet. There are different website, sign language detection data. Kaggle also provides different data sources. You can download and you can use it, but I'm going to use my own data. So what I did guys, I collected my data with the help of my web camera. Okay, so I written a OpenCV code. So that code used to open my camera and I used to give the pose and it used to capture the image. Okay, so this kinds of script you can also write if you want to collect your own images. So let me show you my images, how this image looks like. So this is available over my GitHub. Let me download it. Just a minute. Let me download the image first of all. Sign language data. I got the image. Let me download it. If you train by your dataset, it will work. With other hand, definitely it will work. But make sure you are in the same background. Okay, Naimul. And if you want to create a robust model, that time you can add some more, let's say, environment data, because what happens, the data I collected that time, my background was very simple. It was a white background. Okay, and that's why it was working with my images, I mean, very good. But if you are using this model in the different environment, different background, that time there is some, let's say, wrong detection because of the environment issue, because I collected very less amount of data, that's why. But whenever you are training the actual model, make sure you collect the data from different environment, different background, and lots of images. Yeah, so my zip file got downloaded. Now let me unzip and let me show you how this data look like. So unzip this file. I'm going to also show you how to prepare the data guys. Okay, no need to worry. Image classification wise, we saw how to prepare the folder structure, that means how to annotate the data. Now for object detection also I'm going to show you. So here, see, this is how your image looks like. See, so this image I have collected guys. This is our image. Can you see the image guys? So this image I collected with my web camera. Okay, with my web camera I collected, and that time this was the background I was using. Only the same background. See, the same background I was using. So there are different sign language. Let's say this is yes, then this is hello. Okay, if you do like that, that means this is hello. If you do like that, that means this is yes. And there is another one. This is called I love you. Okay, you can see this is I love you. If you do like that, this is I love you. And there is another one called no. This is called no. If you do the hand like that, this is called no. And please. If you do like that, this is called please. And if you do like that, this is called thanks. Okay, so that's how I'm having 6 level. Okay, 6 category gesture I collected. Okay, now we can collect different gesture. You can search over the internet different sign language gesture you'll be getting. You can move your hand like that and you can collect the image. Okay, it's not a big deal. But the main thing I'm going to show you how we can prepare the data and how we can train a object detection model and how we can do the real-time operation. How we can do the detection operation. This is the idea. So data wise, guys, are you clear? Tell me. Data wise, are you clear? See, I'm using this data because I'm having the data right now. This data I'm having in my system. That's what I'm using. Now here you can use any kinds of data. You can use card data. You can use motorcycle data. You can use helmet data. You can use, let's say, pedestrian data. You can use traffic light data. Any kinds of data you can use, guys. Any kinds of data you can use. Now let me tell you from where you can download the data. Either you can download the data from kaggle.com. Kaggle is also having lots of data related object detection. Even you can use something called RoboFlow Universe. RoboFlow Universe. Okay, RoboFlow Universe. So RoboFlow Universe provides lots of dataset related computer vision. Okay, so here you can filter out. Let's say I need for object detection. Search for object detection. Now see, these are the dataset are available for the object detection. You can do license plate recognition, football player detection, rock paper scissors, people detection, person protective equipment detection. Then you are having face detection, vehicle detection, then construction site safety detection. Okay, let's say this person of wired helmet, then jackets or not. Then you are having animal detection, head detection. See, different data sets are available. Now you can download any kinds of data and you can build your own project. Okay, now don't ask me, sir, why you are using this data, why you are using sign language data, because the dataset I'm having right now in my system, this is called sign language data, and I want to show you the demo with that only. Okay, now you can use the same notebook, same technique, only just try to change your data and create your own projects with different datasets. This should be your task, guys, all of you. Now tell me, guys, so far if do you have any question or everything is clear? Tell me, any question? Yeah, I think everything is clear. Great. So first of all, after collecting the data, you have to prepare the data for object detection. Okay, so we call it as prepared data. Prepare data. Prepared data means, so let's say after collecting the data, you have to do some manual check. Okay, manual check. Let's say sometimes what happens whenever we do real-time data collection, right? So there is a possibility some of the image won't be visible. Some of the image will have some problem. It will not open. That time you have to delete those are the image. So those images, you can see like this image is not good. This is not visible properly. The object is not properly visible. That time what you can do, you can remove that image. You can delete that image. And if some issue with that file that is not opening, you can also delete that image. Okay, so make sure you do these kinds of pre-processing operation. This is called data preparation. Okay, then after preparing the data, you have to do the data annotation. Data annotation. Okay, for object detection. Now how to do the data annotation, let me tell you. Okay, and data annotation wise, we do something called bounding box annotation. Bounding box annotation. Bounding box annotation, that means we have to create a bounding box like that. Okay, on top of the object I want to detect. Does anyone help me how to real-time recognize with camera like webcam after finishing the training on the CNN model? I'll tell you, Nazbul. Okay, how to do the real-time detection with your camera. That part I will also tell you. Just try to be with me. Definitely I'm going to show each and everything. No need to worry. We'll try to create an inter-web app. Okay, for our application. That time I'm going to show you how we can execute our app with our web camera. Yeah. So today I'm going to show you the notebook, let's say inference, that means notebook detection. Next, whenever I'll try to create a project, that means web app, that time I'm going to show the entire, let's say, setup, how we can use our web camera, how we can use our image, how we can upload the image, everything I'm going to show you. No need to worry. Prologue is asking, sir, are you full-time YouTuber or do a job? I also do a job. Prologue, I do development. Recently I joined a company called Quantum Human. This company belongs to United States. So there I'm working as an AI and ML engineer, and I'm working on a product. Okay. Hmm. Then I also work on top of the robotics. I have the robotics lab. I also do these kinds of development, robotics development. Okay. Any kinds of robots, any kinds of device, any kinds of product, I also develop with AI. Then side by side, I also do YouTubing. I also take live classes. I also do content creation. I also have some courses over different platform. Even recently, you will see I'm having my own Udemy profile. So there, I will be keep on updating my course. Okay. Hmm. Yeah, robotics, sorry, computer vision job wise, I already did one job with one of the company from Japan. So I was working as a computer vision engineer there. Okay. So I already contributed with some product, these kinds of robotic product. I integrated robotics, that is computer vision, with that. Okay. So I mean, from there actually I got more interested into computer vision, because computer vision at the end it's visible, you can visualize everything. And I like computer vision because everything we're working with camera, right? So it gives more motivation at the end. Yeah, auto annotation, I'm also going to show you what the, okay, just try to be with me. I'm going to show you auto annotation. Each and everything would be clear. First of all, let me show you the manual annotation, then I will also show you the auto annotation. And let me know, guys, this is my Udemy profile. So DS with Bappy, if you search like DS with Bappy, Udemy. So the first website you can see, DSwithBappy, Data Science and Mentor. Open it up. So this is my Udemy profile. Okay. So here you will be getting some courses I have. So if you're interested, you can check it out. So I'm having lots of plan, guys, in my mind. Just try to be with me. Definitely, you'll be learning a lot, and I'm going to show you some amazing development. Okay, so now let's try to see, guys, how we can perform the data annotation, okay, for our object detection task. So to perform the data annotation, so you can open one website called roboflow.com. Okay, let me show you. This is the easiest way you can follow to perform the data annotation. And make sure you create an account in the RoboFlow. So let me sign in. So here I can delete some of the project I created before. For you, it would be completely empty, guys. Okay, if you are sign in for the first time, it would be empty. But for me, I created some project before, I did some annotation. That's why it's showing me like that. So here I can, fine. Now here you will be getting a button called new project. Okay, click on new project. Now I'm creating object detection project. So let's select object detection. Okay, if you're doing classification, instance segmentation, you can select segmentation. Okay, if you're getting key point detection. But I'm creating object detection project. I'll select I'll select this one. Okay, now here you can give the name, project name. Okay, project name. So here let's say my project name is sign language detection. This is my project name. Annotation group, it is asking for the annotation group. That means what kinds of object you want to detect. And if you see my data now, I am having different object like yes, hello, no, please, thanks, right? So as of now, let's give only one object. I'll give hello. Okay, I'll give only one category. Later on you can also change the category, but just to start the project I'll give only one category here. Then once everything is set, just try to create a public project. Then you can upload your image here. So let's say this is the entire image you have collected. Okay, so this is so here I'm having lots of images. What I will do, I'll open my test folder. In the test I'm having 30 images. Okay, so let's upload all the 30 images here. See, just to show you, I'm uploading only 30 images, guys. But whenever you are having lots of images, you have to upload all of the images, guys. Okay, so let's upload. Just drag and drop. Just drag and drop like that. Okay, if we do drag and drop, it will upload. Now just click on save and continue. Now see, it is uploading all of the data, all of the file. Now here you are having three options: start labeling, auto labeling, and overflow labeling. This is called manual labeling. This is called auto labeling. They are having some auto label tool. That means they're using some multi-model you can use, and you can also hire some people from the RoboFlow. Okay, RoboFlow also gives you some team, so they will also do your data annotation. But for this you have to give the money. Okay, you have to give the money. Okay, this is not the free one. You have to provide the money. Auto labeling also you have to purchase their premium subscription. So as of now we'll go with the manual labeling. So I'll click on start labeling. Now here you can also assign the team. Let's say we're having multiple team. I think just below, guys, you can see. Let me show you. See, guys, just below you can see assign to myself and add instruction. Okay, so here you can invite different members. Let's say you are having 3 members in your team. You can also invite them to perform the annotation. Okay, but I don't want to invite anyone. What I will do, I'll just assign to myself. I'll click here. And now it is ready for annotation. Now I'll click on start annotating. Now see, this will give you this kinds of window. Okay, this is called annotation tool. Now make sure right hand side you can select this bounding box tool, guys, because for object detection annotation we use bounding box. Okay, bounding box. Now let's select this one and start the annotation. You have to select the object you want to detect. So for this demo, guys, I want to detect my hand gesture. Okay, hand gesture, that means sign language. So this is my object. That means this hand is my object till the wrist. Okay, so let's say this is my object and this object name is here I can specify class name. This is hello. Okay, this is hello, because previously we said the hello. No, this is not hello, this is no. So how we can modify? So just click here. Just a minute. Layer, click on the layer, and here you can see hello, right? So you can give this is no. Okay, and save and enter. Now see, it will become no. It will become no. Okay, so once it is done, again click on the next image. Now this is hello. Okay, now again try to select the bounding box and select your object. Now sir, the more good annotation you'll be doing, the more good output you will be getting from your model. Okay, so here I'll be doing a little bit quick because I want to complete all the images, but for you just try to take your time and do the annotation. That's why data annotation is costly task inside computer vision. Okay, so here you have to manually annotate everything, and there are some condition you have to hire some people for the annotation. So there is a job role, guys. If you see data annotation engineer, so there is a job role present, data annotation engineer, remote job. Okay, so if you can also apply for this position, data annotation position. So your task would be only annotate the data. So they will give you bunch of data, you have to annotate them. In the LinkedIn also there are different data annotation positions are available. Okay, so you can search over the LinkedIn jobs. Even there are different websites, they are hiring data annotation engineer. Got it? Now this is hello, so I'll select the hello. That means my first one, and done. Okay, now if you see the class, this is hello. This one is the hello. Okay, now I'll click on the next image. Now again bounding box. Now this is called actually please, I think. Let me check this gesture. This gesture. Thanks. This is called thanks. Okay, you can say this is thanks. Now we'll be writing thanks here. Now save and enter. So thanks has been written, you can see. Now next image. This is again hello. Done. Next image. This is I love you. Let me write I love you. Done. Then next image. This is please. Done. Then you have no again. Done. Then you have I love you. Done. Then you have thanks. Done. Then again thanks. Done. So let me complete for all the images, guys. Okay, one by one. So this is please. Done. This is I love you. Done. This is no. Select and done. Next one is the hi. That is sorry, hello. Done. Then please. Now you can also use your like left hand, okay, to show the same gesture, because here we have to increase the image somehow, and my model needs to see different image angle. Okay, different image angle. Let's say previously I was showing with my right hand, now I'm showing my left hand. If I'm doing also with my left hand, that means this is also a please. So let me select the please. Now this is called yes. So let me write the yes here. Yes is not present. Now next one is my this one. Again yes. Again please. Thanks. No. This is called yes. This is called thanks. Please. And hello. And this is called your no. Yes. Then again yes. Done. See, I have done all of the 28 images. Okay, it's done. Now once it is done, let's get back, and you have to do for all the images, guys. Okay, all the images. Once it is done, get back. Now see, annotated all the images. Now add 28 images to the data sets. Okay, now here you can perform the test split operation. So RoboFlow gives you this kinds of option: split between train, validate, and test. I'll select this option. Now you can also adjust like how many data you want for the training, how many data you want for the validation, how many data you want for the testing. So 70% data I'm keeping for the training, 20% data I'm keeping for the validation, 10% data I'm keeping for the testing. So once it is done, let's add the images. Okay, so I don't need to train the model. I'll close this window. Now I will add my image. Okay, once image is added, let's go to the data sets. Now this is my datasets is available. Now click on new version of the datasets. Now it is asking, do you want to perform any pre-processing? No, I don't want to perform any pre-processing. I'll continue. Now it is asking augmentation. No, I'll continue. Then let's create the image. I'll tell you auto distill annotation stuff in. Even I also have tutorial on my channel. See, auto distill, if you search now, auto distill. So this tutorial is also available. See, image and auto image annotation using auto distill. All the tutorial I have, guys. Okay, you can check it out. So I am having some computer vision playlist. So see, YOLO playlist also available. Then computer vision with RoboFlow, it is also available. So there are different playlists I created. You can check it out, guys. Okay, if you are interested. But I'm going to show you in the live class. Okay, everything I'm going to show you. So once it is done, now what I will do, I'll try to download the dataset. So here is a download dataset option. Now here you can specify which format you want to download the data. Now let's say you are using detect on true. Okay, detect on true framework. That time you have to save your data as a COCO format. Okay, COCO format. If you are using YOLO, that time you have to save your data as a YOLO format. So that's how the framework you are using, based on that you have to save the data, guys. Okay, now let's say the demo I'm going to show you in this session. I'm going to use a YOLO model, YOLO v5 model. So if you want to use YOLO v5 model, you have to save your data with the help of YOLO v5 PyTorch, this particular format. Now either you can show get the download code option, either you can download as a zip file. I will download as a zip file. Now let's click on continue. So see, my data got downloaded. Now let me show you the data. If I go to my download, so sign language data, so let's extract the file. Now I'm going to show you. See, this is the data format you got, guys. Now if you want, you can delete this two file. This is not required. So this is just a metadata from the RoboFlow. I can delete this two file. Okay, now here you are having training folder, you are having validation folder, you are having test folder. Okay, so training and validation you can use during training, test data you can use whenever you are testing the model. See, I'll also show you V12, everything I'm going to show you, not in a single class. Okay, Naimon. I just started object detection. I can't show you everything in a single class. Give me some time. So today, this is the introductory session of object detection. So going forward, we'll try to explore each and everything. No need to worry, okay? Now let me see, guys, what we have inside the folder right now. So in the training folder, you can see, guys, it has created two folders called image and labels, okay? So inside image, it has saved all of the image, okay? All of the image. It has done the annotation. So you can open up the image, you can see. So this is the image, guys, you can see, okay? And in the labels folder, it has saved all of my annotation file. Okay, annotation file. Now let's open up the annotation file. So this is the annotation file for my first image. First image means, let's say image folder, this is the first image. So this image is having this annotation file. You can see this is the same name. And what we have inside annotation file, we have some numbers. Now can anybody tell me what is this number means? What is this number means? So if I open up my RoboFlow datasets, let's open up an image. Now can you see this is a bounding box? And if I want to create a bounding box, if I want to create this kind of square shape, how many, let's say, points I need, guys? How many coordinate points I need? I need X and Y, yes or no? Yes or no? I need X and Y. If I get X and Y, I can easily draw a bounding box, yes or no? Let me open up my pen. So let's say this is here X and this is your Y. If I get two points now, I can easily draw these kinds of box like that. Okay, now here we don't only have we only don't have X and Y, because if I want to get a single coordinate point, I need X1 and Y1, because this is the image. And I told you image start from here. This is the origin of the image. This side you have the X and this side you have the Y. Yes or no? Okay. Now if I want to get this origin point, guys, I have to calculate X1 and Y1. If I want to get this origin point, I have to calculate X2 and Y2. Okay. Now if I open it up, now I think you can understood Why? There are 4 points, guys. This is the x1, this is the y1. Okay, this is the x2, this is the y2. That means these 2 point, and if I'm getting this 2 point, I can easily draw a bounding box, yes or no. And this is the original location of my object, because this is a supervised learning. And we have to pass the output of my data, and that's how we are teaching the model. Let's say this is the location of the object, and your object looks like that. So let me clear my board. Your object looks like that, and this is called thanks. Now how it will identify the thanks? This is thanks, or let's say this is hello. So here we are having the label, integer encoded label. Now what is 0 represents, guys? Can you tell me what is 0 represents? Now to understand this one, just try to open up this file. So there is a file, let me open it up. This data.yaml file, let me open it up. Yeah, so this data.yaml file you can see. Let me delete this 2 file. I'll open up with my notepad++. Now see, guys, this is your data.yaml file. So by default this file would be created if you are selecting YOLO format. Now see, guys, here you are having the training directory. So inside train images you have the training image, inside valid images you have the validation image, inside test images you have the testing image. Now number of classes, how many classes you have? You are having 6 classes. What are the 6 classes? Hello, I love you, no, please, thanks, and yes. And this is the order. Now this is a list, guys, and what is the first item of the list? This is hello. Now if I want to get the index of the hello, guys, what would be the index? Tell me. It would be 0. What is the index of I love you? It is 1. What is the index of no? It is 2. This is 3. This is 4. This is 5. That means in a txt file, whenever you can see, let me show you. Let's say train labels. I'll open this one. So whenever you can see, let's say this is 2. That means what is this label, guys? 0, 1, 2. This is no. And this is the no location. This is the no coordinate point in that image. Okay. Now let me open another file. In the training, I can open it up. Let's say I can open this. Please. 3 means this is a please. You can count 0, 1, 2, 3. 3 means it's a please, and this is the coordinate point of the please in my image. And how my model will understand? Because my model have the image. Okay, image of please. You can see image of please. Okay, and with respect to that, it will also have the label. So level of please, you can see level of please, this one. Okay, now you can understand this is please, and this is the coordinate point of the please. So this is called supervised learning, and that's how we teach any kinds of object detection model. Tell me, guys, is it clear? Yes or no? Is it clear how I am preparing the data, how I am annotating the data, and how I will teach my model regarding my object? Let's say this is the object and this is the name of the object. And this is called annotation file. This label is nothing but your annotation file. Okay, and this is your original image. So after annotating your data, now you are ready to train your model. Okay, now you are ready to train your model. So model training is very simple, guys. But I'm not going to train any kinds of model today because see, I have to first of all show you with the with the faster RCNN. So first of all, we'll try to train a faster RCNN model. Then I'm going to show you how to train the YOLO model. Okay. So today I have completed till data annotation. Like we have prepared the entire data, and next class I'm going to teach you how we can train the model. Okay, how we can train the model, the data we have prepared. Now the data we have prepared, guys, this is called YOLO format. Okay, but whenever I want to train this detect on true, let's say faster RCNN model with the help of detect on true framework, that time I have to save my data as a COCO format. I'll tell you, okay, how to save the data as a COCO format and how we can train the model. Even YOLO training I'm also going to show you. Okay, each and everything I'm going to discuss. So tell me guys, till data annotation, are you clear? Are you clear? Any question? So this is the main challenging part inside computer vision. Okay, once you are ready with the data, now you can pick up any framework, any model, train the model. That's it. If clear guys, please write down clear in the chat, all of you. And if you like the session guys, please hit the like, all of you, hit the like and subscribe to my channel guys. It's a humble request to all of you. Let's hit 50k subscriber as soon as possible. So tomorrow, first of all, we'll explore the faster RCNN. Okay, faster RCNN. Then we'll implement this faster RCNN with the help of detect on true. So this Facebook detect on true will be using this framework. Then after faster RCNN, YOLO. Okay, we'll start with the YOLO. Then once object detection is done, we'll be starting with the segmentation. That means mask RCNN architecture will be learning. So what would be your task guys? Just try to collect any kinds of data. Either you can get it from the RoboFlow, either you can get it from the Kaggle. Actually, I don't have any issue with that. What you have to do, you have to annotate your own data guys. Okay, just try to use RoboFlow platform, RoboFlow data annotation tool and annotate your own data. Okay, first of all, try to learn the annotation because this annotation is a hard task and at the end you have to annotate your data in a good way. So this is super important. And even if you're interested, you can also apply for the data annotation jobs. If you're good with the data annotation, you can also apply for the data annotation jobs guys. Okay, so let's connect in the next class guys. There I'm going to teach you the faster RCNN. First of all, we'll understand the theory of the faster RCNN. Then we'll show you the practical implementation with the help of detect on true. Now any question, let me know. If you don't have any question, I can conclude the session guys. I need computer vision roadmap. I have no degree doing polytechnic, just 12 pass. It is possible to get into job for me. See, at the end skill matters. If you have the skills, definitely you can get the jobs. Just try to see my first session, so there will see the entire roadmap. What are the topics you have to learn inside computer vision, prologue to success. Sir, will you cover image captioning project? Image captioning, I'm going to show you one demo. I think you can understand. Yeah, so training demo I'm not going to show you guys because first of all, let's understand the faster RCNN, because I'm not going to show you the YOLO training. Otherwise people will ask that why you're starting with YOLO. First of all, let's try to understand the faster RCNN theory, and I will also show you the practical implementation with detect on true. Then we'll do the I'll show you the YOLO implementation. Okay, YOLO. With the help of YOLO, I'm going to show you the object detection. So otherwise, each and everything is ready, because in computer vision, what are the in object detection, the component you have to follow: data collection, preparation, data annotation. After that, you have to do the model training, then model inference or model evaluation is also there. model evaluation. Then sixth, you have model inference. So you have two kinds of inference. One is image level inference, one is video level inference. Okay, and video wise you can use camera, either you can use video file. Okay, I'm going to show you each and everything. Fine. Yeah. Then at the end, I'm also going to show you how we can create the web app. Even I'm also going to show you how we can deploy this project. So yes, guys, this is all about from today's lecture. The introduction of computer vision, object detection. And now in the next video, first of all, we'll try to understand our first model in the computer visual called faster RCNN. I'm going to show the practical implementation with the help of Detecton 2. Then I'll move to the YOLO. So thanks for watching, guys. Good night. Bye everyone. And please try to subscribe to my channel, all of you. Thank you, guys.